Hello everyone. Today we are going to discuss another nuclear model, and this model is liquid drop model. The liquid drop model was developed by Niels Bohr and J. Wheeler in 1936 and independently by Frankel on the basis of certain assumptions. This model is statistical in nature. To explain the nuclear properties and structure of nucleus, the liquid drop model considered some postulates. The first postulate is that the behavior of nucleus is comparable to that of the liquid drop. It means nucleus behaves like the liquid drop. In nucleus, which is a homogeneous entity, consists of number of nucleons, means protons and neutrons. Nucleons interact strongly with each other. Next assumption is the liquid drop model considers the collective motion of all the nucleons. Next postulate is the interaction force. That one is the nuclear force which exists in between the nucleons is assumed to be short range, one tending to saturation. This means the nuclear force which exists in between the nucleons of the nucleus is similar to that of the intermolecular forces of attractions which exist in between the liquid molecules of the liquid drop. Next assumption is nuclear force is independent of charge and spin of the nucleus. So the nucleus spin or the charge doesn't affect the strength of nuclear forces. So on the basis of these postulates, the liquid drop model is developed. Now the comparison in between the nucleus and the liquid drop. A liquid drop in which the large number of molecules are present. In the same way, nucleus is also consist large number of nucleons, means number of protons and number of neutrons. Liquid drop is homogeneous and incompressible. Nucleus is also homogeneous and incompressible. We know that density is independent on the size of the drop. In the same way, density of the nucleus is also independent of mass number. The intermolecular force of attraction which exists in between the molecules of liquid in the liquid drop is short range force with saturation in nature. Nuclear force is also present in between the nucleons, which is short range force with saturation in nature. Liquid drop is spherical due to the surface tension. Nucleus is also exhibit surface tension. Large liquid drop capture a small droplet to form a compound drop. In the same way, large nucleus capture a small projectile particle to form a compound nucleus. Large drop, when excited, breaks into smaller droplets, means fission of large drop takes place. In the same way, heavy nucleus when excited breaks into two smaller nuclei, and this reaction we call nuclear fission reaction. Small droplet fuse together to form a large drop, means fusion takes place in between the two small droplets. Lighter nuclei also fuse together to form a heavier nucleus, and this one is nothing but the nuclear fusion reaction. Excited liquid drop may be de-excite by cooling or the evaporation. In the same way, the excited compound nucleus may be de-excite by the emission of gamma rays or the beta particle, alpha particle. Now the advantages of a liquid drop model. The main advantage of this liquid drop model is that this model satisfactorily explain the accurate binding energies of the nuclei and hence their atomic masses by the Weizsäcker equation, which is based on the liquid drop model. This model explains the radioactive decay correctly. This could explain nuclear fission reaction. This liquid drop model explains the mechanisms of low energy nuclear reaction. Liquid drop model explain the emission of alpha and beta particle during the nuclear reaction. This model also explains the nuclear properties in the excited state. Along these advantages, the liquid drop model has some disadvantages also. The main disadvantage of this liquid drop model is that this model failed to explain the magic number. The periodicity in the nuclear properties at magic numbers doesn't find any satisfactory explanation in this model. This model failed to explain the stability of heavy nuclides. This model is not consistent with proton-proton and neutron-neutron pairing effect, which are prominently observed in the stable nuclei. Here, in this model, the collective motion of the nucleons considered than the individual motion. This model ignores the independent motion of nucleus and magnetic moment effect. The application of the model is limited to nuclei with medium masses, but in light nuclei where the atomic weight, atomic mass number less than 20, most nucleons are on the surface, whereas in heavy nuclei with the atomic mass number greater than 150, the Coulombic effect cannot be ignored. Now we have to explain the nuclear fission on the basis of liquid drop model. The liquid drop model can explain the phenomenon of nuclear fission, means the nuclear reactions, on the basis of this liquid drop model. Consider a liquid drop which is spherical in nature. Due to the internal molecular forces of attraction and means the surface tension, liquid drop is spherical due to the surface tension. But when we apply a large external force to this spherical liquid drop, the sphere may change into a ellipsoid shape. Means by applying the large force, the liquid drop doesn't remain in this spherical shape. If the external force is sufficiently large, then this ellipsoid may change into a dumbbell shape, and if the strength of external force is very large, then it may even break at the narrow end, at the neck of the dumbbell. Now, according to four-wheeler theory, the nucleus behaves like a liquid drop. When the nucleus captures a neutron falling on it, it forms a compound nucleus, which is highly energetic. Means we providing excess of energy by bombarding the extra neutron with the nucleus. The extra energy may used for the oscillations in the spherical compound, and this one we can represent with the help of this figure. In this figure, uranium 235 is considered our nucleus, and when it is bombarded with the neutron, it get excited. That one is represented by A. Due to the oscillation setups in the compound nucleus, the shape of nucleus may change at time from spherical to ellipsoidal, and that one is labeled as B in the figure. If extra energy is large, then oscillation may be so strong, and that stage is represented by C. At the stage C, the compound nucleus acquire a shape of a dumbbell, and that dumbbell shape then changes to once again dumbbell, but the two portions are not equal in size in the case D. In this figure, the nucleus is now dumbbell shape, and both part of dumbbell which are not necessarily of equal size carries a positive charge. Means the division of a charge takes place in two portion with the narrow neck. The energy required to change the nucleus from stage A to stage D is called as fission barrier. Now the nucleus is in critical state because once stage D is reached, the final fission into fragments is takes place on account of the repulsions between the two fragments. When the nucleus comes at stage D, then we can observe in the figure the two positively charged nucleus separated, and which is experience a large electrostatic force of repulsion, and they breaks down into the two fragment nuclei with the removal of neutron. So on the basis of this liquid drop model, Niels Bohr and J. Wheeler explain the nuclear fission reaction. Now the next point is meson theory of nuclear force. In the previous lecture, we explained and discussed the composition of nucleus. Nucleus is composed of the number of nucleons. Means nucleus contains the particles, protons and the neutrons. Neutrons are neutral in nature, whereas protons are positive in nature. They carries the positive charge. The protons and neutrons are closely packed in a very small space, that one we call the nucleus. Now if we consider a very close nature of the nucleus, a very packed nature of nucleus, then we can say that the nucleons, means protons and neutrons, are situated very close to each other, and we know that protons carries the positive charge, so there must be a electrostatic force of repulsion exist in between the protons and protons. If we consider such type of electrostatic force of repulsion which operate in between the nucleons, means protons, then we can say that this nucleus will be highly unstable. But if we consider nucleus is highly unstable, then it breaks down to get the stability due to this repulsive force. But such thing doesn't happen in case of the nucleus. Only the unstable nuclei or the heavier nuclei, there will be a fission of nucleus takes place with the elimination of some particles, but in the smaller nucleus such type of nuclear fission we doesn't observe. So it is evident that for the stability of the nucleus there must be some sort of forces which exist in between the nucleons or in the nucleus, which overcomes the electrostatic force of repulsion in between the protons. And this strong attractive force which holds the nucleons together in the nucleus, they called nuclear force. The explanation about the nuclear force is given as, although the exact nature of the nuclear force is not very well known, it is assumed that just like in the molecules, atoms are held together by the exchange of electrons which are situated in between the atoms. In the same way, in the nucleus, the nucleons also exchange some sort of particles which hold the two nucleons together in the nucleus. In 1935, Yukawa suggested that another fundamental particles, he called them meson, must oscillate in between the neighboring nucleons. It means these are the particles which holds two nucleons together in the nucleus. The velocity of the meson particle is close to that of light, and these meson particles are 275 times heavier than the electron. The meson particles may be electrically neutral, they may be positive in charge, or also may be negative in charge. So they interact with protons and neutrons, as a result of which protons may change into neutron and neutron may change into proton. The interaction with proton and neutron is given in the form of equation. When proton interact with the negative meson, then proton get converted into neutron, and when neutron get interact with positive meson, then the neutron get converted into positive proton. So there is exchange of meson particles back and forth between the neighboring nucleons, and this result in an attraction between the neutrons and protons. Two protons or two neutrons attract each other by the exchange of neutral by meson. So in this way, meson theory explains the nuclear force which exists in between the nucleons on the basis of the meson particle which exchange in between the two neighboring nucleons. So this is all about the meson theory which explain the nuclear forces. Thank you.